Hi there, welcome to Vectors 5. This is on kind of geometric problem solving and comparing coefficients. I'm going to forewarn this one to say that because this is problem solving, a lot of it is applying stuff we've learnt. There's one kind of new technique we're going to go through, but in general, this is a hard sheet. Okay, we're going to go through two examples. I'm going to try and go through them in quite a lot of detail. The first one is really a GCSE standard question. The second one is definitely harder and will require a lot of your attention to make sure you're really understanding it. I would say if you're really struggling with this, make sure you're asking questions in class as well, please. So I'm going to start with this question. I've got OBPA is a quadrilateral and it's shown below. And I've got three given vectors, OA, OB and BP. I'm told that Y is a point on AP such that AY to YP is 2 to 1. I want to show that OY is parallel to vector 7a plus 3b. So, the first thing I'm going to do is add a bit more information to the diagram. I tend to like to, if I've got a question with a ratio, I tend to like having my fractions there to help me out. Okay, I know that a to y is 2/3, and I know that y to p is 1/3. It's useful for me. It just kind of saves me a bit of effort later on. And then I'm going to start thinking, okay, so I'm asked to show that OY is parallel to the vector 7a plus 3b. So I need to find an expression for OY. So I'm going to find a pathway. I know that OY is O to B, B to P, and P to Y. Okay, I could go the other way if I want to. There's no danger there, but I've gone this way. Okay. Totally fair enough to go this way if you wanted to. Now, to do this, I know OB, I've got it. I know BP, but I do not know PY. Right? So I want to find PY. Now, I know that PY is a third of PA. That's what I've just said. That's what I did. That's why I've kind of put these fractions there. And so I need an expression for P to A. So PY is a third of this pathway. Okay? P to B, B to O, O to A. Okay? So again, that's my for a third of these. Now I know each of these three, so I can substitute them in. Now P to B is going backwards along this vector, so I've just negated it. B minus 4a as opposed to 4a minus b. B to O is again going backwards, so I'm taking away 4b, and then I'm adding 6a to go from O to A. I can simplify this, that's just a bit of arithmetic. I get down to this, a third of 2a minus 3b, and I can simplify that down again to 2/3 a minus b. Okay, that's my expression for py. 2/3 a minus b. Now using this pathway, I can now substitute each of my values in. I know OB is 4b, I know BP is 4a minus b, and I've now got an expression for P to Y. Okay. Now again, I just need to tidy this up. Okay, there's no negatives in here, kind of outside brackets, so nice and simple. I get 14 over 3a plus 2b. Now at this point, this is our keyword again, show that OY is parallel to the vector 7a plus 3b. So I need to show that I can multiply OY by something to get this vector. Okay, so if I can pull out 1.5, and I've got OY is 1.5 times 7a plus 3b. That means I'm saying that OY times by some constant equals the vector. Okay, at that point, I'm done. Okay, I've shown. That'll get you full marks. If you want to, you can write therefore OY is parallel to the vector 7a plus 3b. But that's what we need to do. The difficult thing about this is just making sure you're being really clear on a diagram, okay, and following your pathways if you need to. I think the key mistake would be negatives around this bit. So as I said, the first question, GCSE standard, really a little bit difficult, but fine if you're taking it step by step. This next question, much harder. Okay, so let's have a look at it. I've got OX is A, OZ is B, and P is the point on OX, such that OP to PX is 1 to 2. I want to let OR equal mu lots of OY, ZR to equal lambda lots of ZP, and I want to compare coefficients to calculate the ratio OR to RY. So there's a lot of information there, and we've got a kind of new technique we're asked to use. Let's break it down though. I'm gonna annotate my diagram to show my two vectors. Okay, so I've got B is OZ and I've got OX is A. I'm told that here, and then because I've got this parallelogram, okay, I can say that these are A and B. Okay. The key thing now I've got P as a point on OX such that OP to PX is 1 to 2. So OP, PX. So 1 to 2. So again, I'm going to put my fractions on there, 1/3 to 2/3. I think that's useful. I find that useful. Now it tells me let OR equal mu lots of OY. O to R equals mu lots of O to Y. So what it's kind of saying is I don't know how far along OY the point R is. Right? The point R is some fraction of the way along OY, and that fraction is mu. I've got Z to R is mu lots of Z to P. Okay, so Z to R is mu lots of Z to P. So I'm saying that again, I don't know what fraction of the way along Z to P the point R is. So this is an unknown fraction of the way along this, but it means it's on both lines, this point R. Okay? And these two fractions of the way along will show me where it is on each of those lines. And what I want to find is the ratio of O to R and R to Y. Okay? Now, that ratio is going to be given to me by this value mu. Okay, because I know once I've found the fraction of the way along, that'll tell me the ratio of OR and RY. Okay, and they were told to do this by comparing coefficients. But in my first instance, I've got something information, right? OR equals mu lots of OY. It seems to me that I should start trying to use that if I can. Okay, so OR equals mu lots of OY. Now, I can find an expression for O to Y, so I'm going to do that. Right? O to Y is A plus B. So OR, this is mu lots of A plus B. Okay, so OR equals mu A plus mu B. Now, I know I want to find the value of mu, but I cannot assume this. I know it's the same. Both of these mu's are the same. I know they're the same value. But I can't just assume a fraction, right? Because if I assume the wrong one, then my point R will be over here and not the one I want, which is at this intersection. Okay, so I want to be able to tell exactly where this point is. So I can't just assume a value of mu at this point. I need some more information. The way I can gather more information in this case is by finding a different pathway to get OR. Okay, I found OR by using OY. I now want to find a different way of defining this vector. So I'm going to use this one. OR is OZ plus ZR. Okay, and that will give me a new expression for OR, which might get me closer to finding this value of mu. Now, OZ I know, it's B. Right? I don't know what ZR is, but I am given this. I'm told that ZR is lambda lots of ZP. So I'm going to substitute that in. OR to OZ, OR equals OZ plus lambda lots of ZP, where lambda is some fraction of ZP in total. Okay. Now, same as before, this was mu lots of OY. I've got lambda lots of ZP, but I can find an expression for ZP. Okay, I can find an expression for ZP. ZP is ZO plus OP, and OP is 1/3 of A. Okay, I've got that on my diagram. So it's negative B plus 1/3 of A. So third A minus B. Okay, so that's my expression for ZP. At this point, I've got OZ, which is B, and I've got ZP, which is this. So I can substitute those in, making sure I've still got lambda there and making sure I've got brackets. I can tidy this up a bit. Okay, I'm going to group together my A's and B's. Just makes it slightly easier, neatens it up. Now this is the clever bit. Okay, this expression is for OR. This expression is also for OR. That means I know that my coefficients of A and my coefficients of B have to be the same. And so now I've got a clever way of me being able to answer this question. I know that these two coefficients need to be equal to each other. I know that these two coefficients need to be equal to each other. Okay? And now I've formed simultaneous equations with two unknowns. Right? Now, I can either, if you're more comfortable, find lambda and then find mu, Or what I'm going to do is rearrange my equation. I'm going to rearrange this top equation to make sure that I can then substitute for lambda and just find mu straight away, okay? Because I know mu is my key fraction because it's involved in OR. Okay? So I'm going to take my first equation and I'm going to simplify, I'm going to rearrange it. So that means lambda is 3 mu. And then I've substituted it into this equation. Okay, so mu equals 1 minus 3 mu. Okay? So this 3 mu has come from this equation here. I can rearrange this to get 4 mu equals 1, and then I can get 1 quarter. Okay? So I know that OR is a quarter of the length of OY. Now that means I've got 1 quarter to 3 quarters, and that means OR to RY is 1 to 3. Okay? If I put this is the fraction of the way along OY that the point R is, that means that this is 1 part and this is 3 parts, so 1 quarter to 3 quarters. Okay? And this gives me your final answer.